synchronization themselves are important aspects of this transmission mode. So all together, that means, let's see, if we transmit 8-tone frequency shift keying, that's what the 8 in FT8 means. There are 8 separate tones. That means that we can, each tone basically conveys a number from 0 to 7, 8 possible tones. That means that if we convert that to binary, that's a 3-bit number. That means that of those 174 bits and 3 QSOs arrays, we can calculate how many symbols actually have to be transmitted. And that turns out to be 174 divided by 3 because each tone is 3 bits, and then add 21. And that ends up with 79 symbols. So on the bottom line here, you'll see that the total length of the transmission itself will be 79 divided by the symbol transmission rate, which is 6.25, 6 1/4 baud, 6 1/4 different tones per second, and that turned out to be 12.6 something seconds. That's the actual length of the transmission. A little bit less than 15 seconds, so that at the end of the transmission interval, the receiving computer has time to decode the message before it has to start transmitting again. All right, so that's basically all the numbers I'm going to go through, but that's the crux of the code and how it works. The messages you're familiar with. Somebody calls CQ, somebody responds with a basic message, and the QSO goes on something like that. A signal report, a Roger, and another signal report, and finally you sign off with 73. And you can shorten these things a little bit. You can combine the Roger and the 73 and so forth. What's important here is the number, the way the individual pieces of information are broken down into the code. And here I've broken it down in that way. The very most basic message of all consists of 2 call signs and another field which can be either a locator, a 4-character locator, or a signal report or Roger or 73, that sort of thing. It turns out each of the call signs requires 28 bits. So that's 28 bits twice, 56 total. Then there are 15 bits allocated for the locator field. That can encode any 4-character locator, 2 letters and 2 numbers. And finally, there are an additional a small group of 6 bits, which allows one to encode a different type of message that tells how to interpret the first 71 bits. Okay, so a second type of message is one that is just free text. You can send anything up to a total of 13 characters. Not very much information, but you can say thanks to your friend or see you later, or some sort of a very short message encoded in 13 characters or less. And the message type has 6 bits, and that allows you to have messages which encode the basic 2 call signs. You can do free text, you can do a non-standard call sign, such as one that has a DXCC prefix added on, or a special event call sign, that sort of thing. And then there are special message types for various particularly popular contests that were of interest to people that we communicated with before devising this list of different possible codes. The North American VHF contest, the European VHF contest, the ARRL Radio Roundup in January each year, the ARRL Field Day, and it turns out there may be other contest modes as well that we can implement in this way. There is also a mode that's been very popular with DXpeditions over the last year or so. We've referred to it as the Fox and Hound mode, where the DXpedition is the fox and everybody else are the hounds, and that allows a fast communication, and I'll go through a little bit more of that in a minute as well. We also can transmit perfectly arbitrary strings of 71 bits for telemetry, for some that has been used, for example, for people that like flying balloons around the world, and they want to send back the altitude and the location of the balloon and information of that type. Well, I mentioned that the connection of WSJT-X and PSK Reporter has been, I think, very, very important in the growth of popularity of these modes. PSK Reporter is a central website run by a man named Philip Gladstone, November 1 Delta, Quebec. I think I had his call sign right, but I may have said that wrong. Anyway, Gladstone is correct. Many people have found PSK Reporter to be an extremely fun tool to keep up on your computer screen next to WSJT-X. So basically, all these spots get uploaded if your computer is connected to the internet to PSK Reporter, and you can follow what's going on. If you can set the display of the PSK Reporter screen to display any particular band, or you can just show all bands. The different bands are displayed with different colors, so you can tell which bands are open over what paths. Yellow is 20 meters, so you can see in this particular slide, 20 meters is open across the Atlantic. Blue is 40 meters, so that's a nighttime band, so you can see over on the right, 40 meters is open at this time between Australia and Europe, and lots of other bands are visible there as well. In fact, let me run through a sequence of bands for you just to show you what it looks like, one band at a time. Here's when the PSK Reporter is set to display only 160 meters. So that's a nighttime band, so it's basically not much happening except during the dark part of the world. And their Europeans are all working each other, and a few of them are working DX into Australia or Japan or into the Middle East. Here's 80 meters at roughly the same time. Again, a nighttime band, mostly QSOs within Europe. Here's 40 meters, again, QSOs taking place in the nighttime part of the world. Here's 30 meters, which is of course a band that has interesting properties and has daytime paths as well as nighttime paths, and you can see the Atlantic is being crossed there by lots of stations, but also from Europe into the Far East. Here's 20 meters. Here primarily a daytime band, but the band hasn't closed yet in Europe. I think these slides were all made a little over a year ago, so the conditions are a little different today, and we'll see some examples of that in a minute. 17 meters is open from north to south. Europeans are working into South America as well as North Americans working into South America. Plus, at least into Southern Europe, the band is open across the Atlantic. Here's 15 meters, and now you can tell that this was at least a year ago, because even 15 meters isn't open much these days. It's been pretty poor. Here's 12 meters, even that quite a number of QSOs going on. And even 10 meters was open from Europe into South America. Much less of that's been happening recently. Finally, back up to the very high frequencies, which were originally MILOVs, and there's a lot of activity on FT8 now on 6 meters. This is what it looked like at one particular time. I think this was about a year ago, when there was lots of sporadic heat taking place over Europe and separately over the US and even occasionally across the Atlantic. And that's lots of fun. When 6 meters opens, as you know, it's often called the magic band. And many people have had fun working DX on 6 meters, even with small setups. When signals are there, they may not last very long, but they're reasonably strong sometimes. And it's fun to work across the Atlantic on 6 meters. There's another example, even at night. This is a much different form of propagation, of course, than the F-flare propagation, and sporadic heat can happen at any time of the day. More often than not during daytime, but that may partly be because everybody goes to sleep at night and there's not so many people on. We've been discovering that multi-hop sporadic heat, for example, across the continent of North America, from the east coast to the west coast of the U.S., is present a lot more often than we would have suspected if we were not using FT8. You can leave your receiver running all the time on the FT8 frequency, and you'll see decodes frequently over paths that you did not imagine might have been open, but they are open, at least at low levels of signal. Just one or two more. I think these are all 6 meters now. Really good openings from the U.S. into the Caribbean, from Europe into Africa, from Europe all the way into the Far East, into India and farther east. You can set up PSK Reporter so that it shows you those stations that are copying your own signal, and that's often fun to do, just to see where you're being copied. Here's a time, I think, when I happened to turn it on with the map zoomed in onto the U.S. I think my antenna was pointed to Europe at the time because we were hearing European signals, but I was being copied off the back of the beam all the way west into Arizona and California. So signal strengths were good at that time, and even off the back of my antenna. Here I'm being copied in Europe and in the west coast of the U.S. at the same time. I think my antenna is still pointed at Europe at this point, but hard to tell. So when the band is open on 6 meters, you can work a lot of stations in a short time. And here's just what my screen looked like on one day a year ago, June of 2018, when 6 meters was open to Europe. And I think the call signs there that are written in blue are ones that I copied within a 5-minute interval. And the ones written in red on the top are the ones that I actually worked in that same 5-minute interval. So this is a way of working stations reasonably quickly, not as fast as you could work them in a CW pileup if you were the DX operator and you were controlling the pileup, but still it's fast enough that you can work a lot of stations in a reasonably short time, and many people find that to be lots of fun. Here's just one more example of my signal being copied over most of North America. You could do this same thing for yourself, and I'm sure many of you have done so. We had even a few openings last year in June during the sporadic east season into the Far East, and here's a day when Japan and China were being copied and worked all over the U.S. And I worked a few of those myself. It was a lot of fun to add a few additional countries to my 6-meter DXCC. Let's say a few words about the FT8 de-expedition mode. So this is the mode where we've got one station that everybody else wants to work, perhaps a de-expedition to some distant island. We developed this mode together with the group that did the expedition to Baker Island about a year ago, KH1/KH7Z. So we put together a way in which we could try to maximize the QSO rate that could be achieved by the Fox, by the distant station that everybody wants to work. And the mode has been used now by many de-expeditions over the past year, and it's possible to push the QSO rate at a maximum up to several hundred per hour, up to as much as 400 per hour. Which is very good and interesting for these de-expeditions that want to put as many thousands of stations as possible in their log over an interval of a week or so. One of the special features of the de-expedition mode is that it allows the Fox station to transmit several signals at once and work several stations at the same time. So instead of just one transmission, one station being called every 15 seconds, you can do as many as 5. Many signals just stacked side by side. And the waterfall that you would see on your own WSJT-X screen would look something like this, where when the Fox transmits, there can be several signals side by side. Each signal is 50 hertz wide, and they're separated by 60 hertz. So the 5 signals occupy a total bandwidth of about 300 hertz. Down near the low end of the spectrum. And for those of you who can see it, so this is the Fox. Here he's got 5 signals. Here he has only 3. Here 5 again. And in the alternate 15-second interval, all the hounds over there calling the Fox. Many of you, I'm sure, have experienced this already and seen how it works. Some of the derivative programs that have been taken computer code from WSJT-X and copied it and then made some changes or in the user interface or the way that the program looks on your screen have implemented the expedition mode in a somewhat different way, and it's, I think, somewhat confusing. Among other things, we did not allow the Fox to transmit in the standard FT8 band. We asked him to use some other frequency, a special frequency for the de-expedition, and that sort of moves all that activity out of the standard FT8 subband. And I think that's been effective on the whole, but some of the other programs that have copied code from WSJT-X have not included that restriction, so that sometimes you will see people using what essentially is this multi-streaming mode to make rapid QSOs with more than one station at a time. We thought that was not a very good idea, but anyway, that's not apparently everybody's opinion. I'll just say a few more words about the way FG8 is implemented in WSJT-X. And this is maybe a good